2 billion years ago, Earth looked nothing like the planet we call home today. No humans, no animals, not even the forests or oceans we know. Instead, the world was a strange and dangerous place, filled with mysteries, deadly climates, and microscopic life that was just learning how to breathe oxygen. Tonight, let's travel back in time and uncover the incredible story of Earth 2 billion years ago. The World Chapter 2 billion years ago. Close your eyes for a moment and picture this. You open them to find yourself standing on Earth, but not the Earth you know. The year is 2 billion years ago. There are no cities, no forests, no animals, and not even a single blade of grass. The world feels alien, almost like you've landed on another planet. The air is heavy with strange gases. The sky above carries a rusty orange or hazy blue tint, and the oceans before you are dark, murky, and filled with chemicals that would be deadly to us today. This is the Proterozoic Earth, a planet in the middle of becoming something entirely new. The land beneath your feet is raw and unfinished. Continents are just beginning to take shape, rising slowly from the oceans through volcanic eruptions and tectonic shifts. These early land masses are nothing like the continents we know today. They are barren, rocky wastelands, covered with volcanic plains, mountains still smoking from eruptions, and rivers that flow not with clean water, but with mineral-rich, acidic streams. Imagine walking across a landscape that looks more like Mars than modern Earth. Dry, cracked surfaces under a sky filled with volcanic ash. The oceans, stretching endlessly before you, are unlike the blue waters we take for granted. They are dark green or even black in color, filled with iron and sulfur. The water carries a metallic smell, almost toxic, and beneath the waves lie massive colonies of tiny life forms, microscopic organisms clinging to survival. These oceans are their kingdom. They build strange dome-like structures called stromatolites, and from their photosynthesis, they are releasing a gas that will soon change the planet forever: oxygen. But here's the twist. 2 billion years ago, oxygen wasn't abundant in the air. In fact, if you tried to breathe, you'd suffocate within minutes. The atmosphere is still mostly made of nitrogen, carbon dioxide, and methane. Oxygen exists only in trace amounts, and ironically, it is considered a poison to many of the life forms thriving in this ancient world. For these microbes, oxygen is as dangerous as chlorine gas is to us. Yet slowly, quietly, they continue pumping it into the seas and sky. Around you, the climate swings wildly. Without the stabilizing systems we rely on today, Earth is a world of extremes. The days are shorter, only about 20 hours long, and the sun, while still bright, gives less energy than it does now. Storms sweep across the oceans, lightning cracks against the volcanic peaks, and the young continents constantly break apart and smash back together in slow, powerful collisions. This is not a planet ready for humans. It is a planet in transition. Everything feels hostile, yet every piece of this alien environment is building toward the Earth we would one day inherit. The stage is set, the actors are arriving, and the first act of the story, the rise of oxygen, is about to begin. The Great Oxidation Event. Imagine standing on the shore of this ancient world. The ocean waves crash against jagged rocks, and the air feels heavy, almost unbreathable. All around you, invisible forces are at work, forces that will forever change the destiny of Earth. At this moment, 2 billion years ago, something remarkable is happening. A silent revolution led by the tiniest organisms imaginable. Beneath the surface of the oceans, microscopic cyanobacteria float in vast colonies. They are small, almost insignificant, but they hold a power no other life form possesses: photosynthesis. With every ray of sunlight, they capture energy, split water molecules, and release oxygen as waste. What seems like a minor chemical reaction to us is, in truth, the beginning of one of Earth's greatest transformations. For hundreds of millions of years, these tiny architects have been at work, slowly pumping oxygen into the seas and skies. But oxygen, in this world, is not a blessing. To most ancient microbes that had thrived in a low-oxygen environment, it is a deadly poison. Imagine a city where the air suddenly fills with toxic fumes. Chaos, collapse, and mass extinction would follow. That is exactly what happens on Earth. Whole populations of anaerobic microbes are wiped out, unable to survive the oxygen-rich pockets forming in the oceans. In a sense, the Great Oxidation Event is Earth's first mass extinction. As oxygen builds up, it reacts with the iron dissolved in the oceans. The seas turn a rusty red, and layers of iron oxide settle onto the seafloor. These deposits, known today as banded iron formations, are the ancient skirs of this oxygen revolution. If you could dive beneath the waters, you'd see clouds of red particles drifting down like underwater snow, coating the ocean floor in layers that would harden into stone. Billions of years later, humans would mine the very iron to build their cities and machines, never realizing it was created during this dramatic event. Above the oceans, the skies begin to change. The methane-rich atmosphere, once thick and hazy, starts to break down as oxygen levels rise. The blanket that kept Earth warm thins, and global temperatures plummet. The planet shivers. Ice creeps across the continents. Some scientists believe that this oxygen shift may have triggered one of the earliest Snowball Earth phases, where glaciers reached as far as the equator. The world becomes a frozen sphere, yet beneath the ice, life clings on, adapting to the new environment. This transformation is slow, stretching over millions of years, but its consequences are permanent. The Great Oxidation Event is more than just a change in chemistry. It is the setting of a new stage for life. Without it, complex organisms, from plants to humans, could never exist. It is almost as if Earth, through trial and error, was preparing itself for the future. So here you stand on the edge of this ancient ocean, watching a deadly gas creep into the air. For the microbes, it is the end of their world, but for us, it is the beginning of everything. Oxygen, the invisible thread that ties every breath we take, was born here, in the crucible of Earth 2 billion years ago. Life in a microbial world. Picture yourself walking along the edge of a shallow sea 2 billion years ago. The coastline is silent. No birds, no insects, no sound of animals, just the steady crash of waves against the barren rocks. But if you look closer, you'll notice strange, rounded structures rising from the shallow waters. They look like stone mushrooms, stacked in layers, stretching across tidal flats like a city frozen in time. These are stromatolites, the skyscrapers of the microbial world. Stromatolites are not lifeless rocks. They are living, breathing colonies of cyanobacteria layered over centuries of growth. Each morning, as the sun rises, these tiny architects awaken and begin their silent work, capturing sunlight, releasing oxygen, and building the very foundations of Earth's atmosphere. To us, they may look simple, but in this ancient world, they are the dominant life form, the rulers of Earth. If you could shrink yourself down to the microscopic scale and dive into their world, you'd enter a bustling metropolis. Threads of slimy green bacteria weave together, trapping sediments, building layer upon layer, century after century. In the dark waters beneath, other microbes thrive, feeding on sulfur and iron. The ecosystem may be invisible to the naked eye, but it is vast, complex, and surprisingly organized. And yet, this life is fragile. The oxygen these microbes release is both their greatest creation and their greatest danger. For billions of years, Earth's oceans had been home to anaerobic organisms that thrived in oxygen-free conditions. Now, as cyanobacteria spread across the planet, they are rewriting the rules of survival. The world is changing, and not everyone will make it. Imagine a silent battlefield stretching across the oceans, where invisible armies of microbes fight chemical wars for dominance. But within this struggle lies the blueprint for everything to come. These microbial mats are not just surviving, they are transforming the planet. They fix nitrogen from the atmosphere, making it available for other organisms. They alter the chemistry of the oceans, paving the way for new forms of life. They are the quiet engineers of Earth's future biosphere. As you walk across the tidal flats of this ancient Earth, you realize that every breath you take today traces back to these simple colonies. They are the ancestors of every forest, every coral reef, every human city. Without their oxygen, life as we know it would have been impossible. It's humbling to think that our story, the story of humanity, began not with towering dinosaurs or mighty mammals, but with carpets of green slime stretching across ancient shorelines. The world may appear empty, but it is alive with hidden potential. The cyanobacteria are unknowingly setting the stage for complexity. For now, Earth belongs to the microbes. But deep within their chemistry, the seeds of future plants, animals, and humans are being sown. This is the calm before the storm, a world ruled by slime, preparing for evolution's next leap. When Earth froze over, the world shifts again. Imagine standing on the edge of an ancient continent 2 billion years ago. The sky above darkens, the winds grow sharp, and the temperature begins to plummet. Slowly, ice creeps across the land, first clinging to the mountain peaks, then spilling down into valleys, and finally stretching outward until it swallows everything. Before long, the horizon you once saw as rocky and volcanic is now a vast expanse of glittering white. Earth has entered one of its most extreme chapters, the Age of Ice. Some scientists believe that during this time, Earth may have become a snowball planet, a world almost entirely frozen from pole to pole. Picture it: the ocean sealed under sheets of ice dozens of meters thick, continents buried beneath glaciers, and the equator itself cloaked in frost. The planet you're standing on now looks less like a home and more like a frozen moon orbiting a distant star. But how did this happen? The Great Oxidation Event had transformed the atmosphere. Methane, a powerful greenhouse gas that once kept Earth warm, was destroyed by the rising levels of oxygen. Without that insulating blanket, the planet cooled rapidly. The sun, weaker than it is today, couldn't provide enough energy to keep the climate stable. The result was a plunge into an ice age so severe it threatened to erase the progress of life itself. And yet, even in this frozen silence, life endures. Beneath the thick sheets of ice, in cracks and pockets of liquid water, microbial colonies cling to existence. In geothermal vents deep on the ocean floor, life flourishes in complete darkness, feeding on the heat and chemicals spewing from Earth's interior. It's almost as if the planet is hiding its most precious creations, keeping them safe through the cold until the world is ready to thaw. The glaciers grind against the continents, reshaping to land with their crushing weight. Volcanoes erupt beneath the ice, pumping carbon dioxide back into the atmosphere. For millions of years, the balance tips between ice and fire. Slowly, as volcanic gases build, the greenhouse effect strengthens again. Temperatures rise, the ice sheets begin to melt. Rivers of water carve their way across the land. Ocean waves return, crashing against rocky shores. The Snowball Earth begins to thaw. Imagine the scene: vast walls of ice collapsing into the sea, giant floods roaring across barren landscapes, and the planet waking from a frozen slumber. It is violent, it is chaotic, but it is also renewal. With the melting of the glaciers, nutrients locked in the ice pour into the oceans, sparking blooms of microbial life. The Earth is reborn, shaken but alive. This cycle of freeze and thaw is more than just a climate shift. It is a test of resilience. The organisms that survive are stronger, more adaptable, and more prepared for the future. Earth, it seems, is sculpting itself through hardship, ensuring that only the toughest life forms continue the journey. The planet has survived its deepest winter, and with it the blueprint for complexity grows stronger, the legacy of an ancient world. The ice has melted, the skies clear, the continents shift once more. As you stand on the rocky shores of this ancient Earth, it feels as though the planet has taken a deep breath after surviving its greatest trial. The frozen silence has given way to renewal, and beneath the waves, something extraordinary is stirring. This is not the end of Earth's story. It is the beginning of something far greater. For billions of years, life has been simple, ruled by microbes. Yet the hardships of the Great Oxidation Event and the frozen Snowball Earth have left behind a world transformed. Oxygen now lingers in the atmosphere in greater amounts, reshaping the chemistry of oceans and skies. The stage is being prepared for a revolution in biology, the rise of complex cells. These new cells, known as eukaryotes, will eventually give birth to plants, animals, and every living thing that carries the spark of complexity. It's almost poetic. The very gas that once poisoned life is now its greatest gift. Oxygen makes energy production far more efficient, allowing organisms to grow larger, stronger, and more diverse. Without this, no forest could stretch across continents, no animals could swim through oceans, and no humans could one day walk on the surface of the moon. The struggles of Earth 2 billion years ago planted the seeds of possibility. Look around this world, and it still feels empty. There are no trees swaying in the wind, no insects buzzing in the air, no mammals running across the land. And yet, hidden in the shadows, the groundwork for all of that is quietly being laid. The microbial mats and stromatolites continue their patient work, the oxygen levels climb higher, and the continents slowly drift into new arrangements. Every change, every shift, is setting the foundation for a more vibrant Earth. If you could fast forward through time, Yi Ao would see the miracle unfold. Single-celled organisms begin to cooperate, fusing into larger, more complex beings. Oceans explode with diversity. Tiny multicellular organisms appear, testing new forms of life. The barren continents will eventually bloom with the first primitive plants. The atmosphere thickens with oxygen, turning the skies bluer, the seas clearer, and the land fertile. What began as a hostile alien world 2 billion years ago is slowly, steadily, becoming the Earth we call home. And perhaps the most remarkable thought is this: without those ancient struggles, we would not exist. If oxygen had never risen, if Earth had never frozen and thawed, if microbes had not survived against impossible odds, then humanity would never have walked this planet. Our existence is not separate from this story. It is the direct continuation of it. We are, in every sense, the children of a 2 billion-year-old journey. So as you take a breath today, remember where that oxygen came from. Remember the frozen oceans, the green mats of microbes, and the storms that shook the continents. They were not just random events. They were the first chapters in the epic story of life. 2 billion years ago, Earth was a strange, alien place, but it was also the place where everything began.